All right, hello once again, Jeff Scott of Rankin Technical College. In the last lecture, I gave you kind of a little preview of what we're going to be talking about as far as being able to access multiple tables by using a join or join operations. So our objectives are fourfold: perform basic join operations, join tables with shared column names, use the condition join, perform union operations. As mentioned in here, it's called relational database management system. So we want to be able to relate the data in one table with the data in another table. All right, one way to do this is a join operation. And as is mentioned right here, a join is an operation that matches rows in one table with rows in another table so that the columns in both tables can be placed side by side in the query results. You can join as many tables as you want. You can even join tables from different databases together as long as they have a common field. So in this chapter, as the author mentions, they discuss a number of operations that combine data from multiple tables, including joins and unions. We'll talk about unions later on in the chapter. So, as mentioned here, one of the simplest types of joins to implement is the comma-separated join. All right, that's a bad one. Again, typically you don't want to do this. This says give me everything from the inventory and the performers databases. Okay? There's the inventory. There's the performers. Now notice we do have a field in common, and that's the performer ID field. All right? But we're not using that. So we're going to get this. We're going to get what's called a Cartesian product join. In that case, as they mention here on page 255, a list of each row in one table is joined together with each in the other table. So if this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and this has 1, 2, 3, 4, 5, 6, 7, 8, 9, we're going to get 99 possibles back. Almost always when that happens, it's a mistake. You didn't mean to do it. All right? Now, years ago when I was working at another institution, a friend of mine and I, we developed a database together. And that database had in it 6,397 records. All right? When a student actually joined, that table had 6,397 records in it. One of the ways that you can do a join is to do what's called a self-join, and we'll get into that in a little bit, but that's joining the table on itself. And this student did that, not purposely, but accidentally. So notice when you do that, you get back 40,921,609 records. And when the person did this, they typed in select this, this, etc., and hit enter. So what the system was attempting to do was to print out on their screen all 40,921,609 combinations. Again, virtually 100% of the time when you do a Cartesian product join, it's an accident. You did not mean to do so. All right. You can generate more meaningful results when you use an equijoin. That's what I just showed you. As mentioned, that's where the type of join that equates the values in one or more columns in the first table with one or more corresponding columns in the second table. Now, I did a different example than the author does here, so let's go back and look at one of mine again. We'll look at this one. So select the first name from the employees table, the last name from the employees table, the department name from the departments table, the salary from the employees table. but we want to refer to employees rather than typing employees dot or departments dot. We want to give each one of them an alias. So employees will be referred to as E and departments as D. The key line is right here. This is the join part right here, where the department numbers on the two tables are identical to one another. The reason that that's important is if I select, let's say, the department number, the dep number from employees, and then I select dep number from departments, you'll notice I've got 1 through 6 here, and I've got 1 through 6 in here also. So this will join the 1 from here with the 1 from there, the 2 from here with the 2 from there, the 5 from here with the 5 from there, etc. That is an equijoin. So the author says once you do an equijoin, and this is shown here in the text on the middle of page 257, once you do this equijoin, you've refined the query results down to just the most essential information. It says, of course, you can create all sorts of queries depending on your needs as long as you follow the basic guidelines. The from clause must include every table that you're joining together. You virtually always have to have a where clause, where you define a join condition or conditions. Otherwise, you're going to get a Cartesian product join. Now, going back to our example, remember, now we can use something from the last chapter here. I can do a select, count star from employees. Oops, forgot to put the star in parens. So there's 12. Sorry about that. So there's 12. All right. Then I want to select count star from departments. And there's 6. Finally, I want to select count star from zip, city, state. And there's 4. Why am I showing you that? Because if we joined all 3 tables together and didn't put a where clause, all right, it would be 12 times 6, which is 72, times 4, which is 288. So I'd get 288 records returned when I say select star from employees, comma, departments, comma, zip, city, state. Let's verify that. It's giving me every combination, and there's 288 rows. That wouldn't be what I want virtually 100% of the time. That's why you need the where condition. All right. And you can use what are called typically theta joins, where instead of using equal, you can use less than, greater than, between, and other things, but probably close to 100% of the time, you're going to be using some derivation of equijoins because they are the most common join operation. All right, using correlation names. As the author mentioned earlier, you must qualify your column references by adding table names to these columns that share a name. All right, what does that mean? That means this. Looking at the examples that we went over before. All right, I'm going to go back to this one right here. Okay? So not only now do I want to put in the department name, okay, I want to put in the department number. And I'm purposely not putting an E dot or a D dot in there. I'm purposely not doing that. And my guess is I'm going to end up getting an error when I do this. All right, and the keyword there is ambiguous. The system doesn't know for department number, do I want to grab it from the employees table or do I want to grab it from the departments table? The good news for us is it doesn't matter which one we use as long as we use one of them. So if I come in here and I say E dot, unknown C dot city. Oh boy, I didn't want the city in here, I'm sorry. So let's get rid of that. Oh, and now we left the department number off again. That's okay. So we'll fix it. What we have here, column department number and field list is ambiguous. Select this, E dot department number. All right, so I'm going to put that in there. Yep, oops. E dot department number. From employees, E, departments, D, where E dot department number equals D dot department number. Hopefully I didn't make any typing mistakes, and I did not. All right, so there we did it, and in that case, we grabbed the department number from the employees table. But let's run the same query one last time, and let's get the number from the departments table instead of from the employees table. And you'll notice we get 1122, etc., the same information. All right, so it doesn't matter which of the two tables, we get the department number field from. So the author says, as stated earlier, you must qualify your column references by adding table names. It's a good idea to always qualify, and that's what I showed you. All right, I also showed you what they call a correlation name, as P, as C. I call those an alias because that was the verbiage that I was taught to use. It really, what is the old saying? 6 of one, half a dozen of the other. It really and truly doesn't matter. If you do use this correlation name or alias, you must do it right after the table name, and then anywhere before it and anywhere after it, you must then, instead of using the name of the table, you must use the correlation name or alias. All right. You use the as keyword with this, which is, as it says here, this is the bottom of 258. This makes the SQL statement much simpler. Let's just put it this way. At a minimum, it means you've got less typing to do. Creating joins with more than 2 tables, I showed you an example of that one. They show you an example in here also. So in there, we need 2 different conditions or more conditions. Here we're joining 3. We're this and this. All right, at a minimum, I'm not worried about the type name right now, but it's this. So if you're joining together 3 tables, at a minimum, you'll need 2 conditions in your where. 4 tables, you'd need 3 minimum, etc. All right? Let me check my time here. I'm at 14 minutes, and we're about to go into cross joins, self joins. I think what I'm going to do right here is break this up. This seems like an opportune place to break this up, and I will come back in just a couple minutes and finish up the chapter.